We've got Scotty Pate, the founder of DAGCTL, who's going to talk to us about multi-tenant Kubernetes. Take it
Correct.
away, man.
Test. Am I on? Okay. Awesome. Perfect. Cool. So we're going to talk today about systems design in general, and then very specifically applied to multi-tenant architecture and Kubernetes, just because that's a system that we all use. Show of hands, who considers himself a developer? Nice. Awesome. Any like back-end platform DevOps? Awesome. Cool. So we got the real nerds here. What about web developers? Security? Can we get her? No, I'm just kidding. Cool. So we're going to talk about systems design a little bit. So who am I? So some personal things. That's my wife, my lovely wife of 20 years. My puppies. I'm a Destiny player. Any other Destiny players? Also sad. Yeah. Cool. Some professional history. So joined the military right out of high school. Got a dream job at a company called GitHub. Microsoft destroyed it. And then I found a great startup called Auth0. Okta destroyed it. So now I do my own thing. So I'm an expert on billion-dollar companies buying beautiful things and destroying them. So you may have seen this meme. Basically, the top says vibe code it into existence. The bottom part says engineer it to make it good. And so basically the idea is you vibe code your V0, and then you iterate on it and apply some sort of engineering, some strict discipline to it to make it good. The main premise of my talk is sort of why this is wrong. It may be very obvious to developers why that's wrong. It's not very obvious to your managers or to your bosses or to your CEO, who's maybe their nephew told them, hey, I built a web app over the weekend, and why can't the team ship that feature in a couple of weeks? And so for us, we know that that image is wrong because the first image, the system design is already in place, right? The fuel system that rocket uses was developed in the 50s. The engine arrangement on the rocket is the same. The number of engines is the same. The second image, the cleanup, is actually the easiest part of that development. And so that misunderstanding leads to some funny situations, right? So this is a developer, a non-developer who came to Cursor, developed a web app, bragging about it, was very happy, and then 2 days later says, hey, well, I'm being attacked and I'm not technical and I can't really understand what's going on. It also leads to things like this. And so I've actually heard a lot of, or not a lot, a fair amount of AI skepticism over the talk. So I included this slide to counter any accusations of me being an AI skeptic. I'm not a naysayer. I use these tools every day. I use them regularly. I just use them in proper harnesses with engineering rigor applied to that in much the same way that we did traditionally before they existed. So this is one of my favorite quotes about systems design, and this is from a he called himself a cybernetician, right? Which was a concept of like business operations back in the 50s and 60s. And it says the purpose of a system is what it does. And that is a statement that is so patently obvious that it seems like it has no insight until you've worked in an organization where all of the systems produce undesirable outcomes and everyone is agitated about it or upset about it. This is a bit more nuanced view of that. And so this quote says, the system to a large extent causes its own behavior. An outside event may unleash that behavior, but the same event applied to a different system is likely to produce a different result. And so that means when you're involved in systems design, you're literally choosing the outcomes of what's going to happen when your applications are deployed. So the joke way to demonstrate this point is the joke about the man who keeps adopting kittens from the local animal shelter. And on like the 15th kitten, the owner of the shelter says, hey, you're adopting a lot of kittens. Like what's happening? He says, oh, the alligators keep eating them. And he says, well, it seems like you're feeding kittens to alligators, right? And so that's sort of the like joking version of this idea. So what is systems design? So systems design is deep waters. It applies to all kinds of topics, not just technology. It applies mostly not to technology. And it is the study of how systems interact and produce their outcomes in the whole, right? So all of the moving parts, all of the interfaces. And it matters because those quotes that I just showed you sort of illustrate the point that when you're doing systems design, you're choosing the possible outcomes. You're constraining what your systems can do. You're creating what is actually going to happen whenever you deploy your code, whenever you run your systems. And so why now? So I've also heard a lot of talk. Jared's talk yesterday was pretty big on this about friction being removed and that not being a great thing. And so LLMs have basically made code pretty cheap, and they've sort of removed the friction of systems design, but all of the problems still exist, right? So I think we have to be more intentional about it. Cool. So who can benefit from these ideas? So in general, anyone that is building a solution in a complex for a complex problem. So managers, owners, of course, engineers. You're building a team. You're constructing like process. You're involved in systems design. So the general thesis of this is that when you sit down at your Claude prompt or your OpenAI prompt and you say, build a web app that does X, that prompt is going to make decisions for you that you are not going to be aware of, right? And you can't allow that to happen because it's by making decisions about systems design, it's going to make decisions about outcomes. You have to cognitively own all of your systems design. You have to understand it completely. You have to know which implementations are in effect. The implementation is less, the cognitive gap for your implementation is actually less risky than the cognitive gap for your systems design. And so like if you have, let's say you have a system that reads from a database, it may query that database to get users when a user logs in. How it does that is maybe not as important as knowing that that happens, right? That you have a web app reading from a database. And so this concept that you can vibe code something and then make it good is also not true because you have to there's a concept in systems thinking called the viable systems model, and that there are a base set of conditions that have to be met for a system to even be viable, to be iterated. And so iteration is a privilege, right? Like refinement is a privilege. You earn that through sound systems design. How many have worked with applications that are just dead in the water, right? There's no refinement on it. It has to go back to V0, right? And so this is sort of the core idea. So this is spoken like a veteran computer scientist, which she was. And it says, we build our computers the way we build our cities, over time, without a plan and on top of ruins. The ideas behind systems design are things that will make you radical in your companies and in your organizations because these are so uncommon. These ideas and patterns of thinking are so uncommon. Cool. So when you have poor design, so it freezes your systems, but it also causes altered human behavior in your engineering teams. So who has worked with a database table maybe that everyone in the company touches, and no one can alter the table because everything will break, and no one really knows why it will break. And so that table is just etched into the foundations of the company, and it will live as long as the company lives, and it will never change. And so what happens is a development team comes to that and they say, hey, we need to change that column, but we can't change this frozen column. So we create a new table that's a copy of that table. And now we have two copies of that data. We have increased storage costs. We have increased compute. And so literally the data model that you picked to back that table altered the behavior of the engineers on your team, right? And like you weren't even aware that a data model could do that. So your coding assistants are not going to skip this decision. You're just not going to be aware of it, right? So in our build a web app that does X prompt, it is going to pick a JavaScript framework probably, and that has implications. Um, like in my testing, it typically picks Next.js. You should know that, and you should know what does this mean for the future of this application that I'm building. Um, like that is the component you have to be most aware of. But you have you have competing incentives from that LLM model. Jared spoke about sort of like the idea that the machine has the complete theory of the thing, and you're just going to trust it and accept that it has the complete theory of the thing. It really doesn't, right? You're supposed to bring that to the implementation, and that's sort of like something you have to add friction back in, and we're going to talk about some ways to do that. Cool. So one of the things that I like to do is I like to use frameworks as containers for complexity. And we're gonna go through a lot of these frameworks as applied to Kubernetes. Um, there's this concept that complexity can't be reduced; it can only be moved, right? So you can't eliminate complexity, but you can decide where it lives. I like it to live in frameworks because that means I don't own it. There are times where that is not appropriate. And so a common, well, I don't know how much this is true now, but a common response that I would get from developer teams that I worked on is, are you going to fight? We don't want to use this framework because we don't want to fight it. And that may be true. Like if you have an actual rare use case, maybe something that's a strategic advantage for your company, okay, maybe there's actually not a framework for it. But like if you're connecting to Postgres and you're reading data, there's a framework for that, and you should use it. And so the test of that is, do you have a unique problem? If you don't, then why are you fighting the framework so much? And you should sort of like inspect on your own use case because maybe there's something about it you don't fully understand yet. Sweet. Okay, now to the meat of how this looks for developers. Who's familiar with Kubernetes, like what it is, what it does? Yeah, okay, so that's why I picked it, right? Kubernetes is deployed in like 80% of companies. Everyone uses it. It's sort of like a shared set of resources. And so if you're not familiar with it, it's basically just a hosting framework for services. It's a way for developers to deploy web applications, deploy backend APIs, deploy various code that they want to run and ways that it interacts with other code running in the same cluster. Cool. So everyone uses Kubernetes. SaaS companies obviously are very heavy users of it. I've also made heavy use of it as in platform teams, right? So internal tooling that other teams use. Maybe you host something that multiple departments in your company use. Kubernetes is a good subject for that as well. And then why does it matter, right? So like, why would you even want to do multi-tenant Kubernetes? And so the primary reason is cost, right? You don't want to have a cluster for every implementation. And so you have multi-tenant Kubernetes for the same reason you have multi-tenant apartment buildings, right? It's like it's an efficient way to house tenants in an like economical way. So all of the uses of multi-tenants in Kubernetes, but Kubernetes has no tenant object. So what is that? And so you can see the primitives that Kubernetes supplies you are logical boundaries that exist only in Kubernetes, like namespaces, role-based access control, network policies, and resource quotas. The tenant definition is a logical definition that you bring, right? You're imposing a logical definition onto the cluster, and you're comprising that definition of the various resources that Kubernetes has as primitives. So typically a tenant is sort of the same as the tenant in an apartment building. A tenant is someone or whoever must never see, starve, or break another, right? So you can imagine the situation where if you lived in an apartment and someone plugs in their Bitcoin miner and it takes 100% of the electricity to that outlet, that's obviously not good, and you have to have protection in place to prevent that, like circuit breakers. So we have the same sort of primitives that you have in residential living. We sort of have analogs to those in this application. Okay, so we're going to spend some time here. So there are no solutions to this, right? There are a series of trade-offs, and the implementation is as varied as your use case. So this is sort of a sliding spectrum, left to right. We call it soft to hard tenancy. And so soft tenancy is just logical boundaries on the same machines, right? So a Kubernetes cluster is multiple machines, so like multiple VMs. A soft boundary or a soft tenancy boundary is just logical boundaries on the same machines, even the same cluster. They share a control plane, but you're using those primitives like network policies and resource limits to impose sort of restrictions and caps on tenants on the same cluster. And so that's really common for internal platform teams, right? If you're all in the same VPN, someone's going to log in with Okta, and they're going to that's like a perfect candidate for soft tenancy. And then the spectrum goes all the way to hard tenancy, which is like everyone gets a cluster. Maybe there's like a shared API layer where onboarding happens, but everyone gets their dedicated hardware, their dedicated control plane. And so this is really common in like regulated, like B2B SaaS and regulated industries like finance or defense or healthcare. And then there's a spectrum of everything in between, right? So there are tools for virtual clusters, which is running on the same machines, but it's provisioned as if it's actually a virtual cluster. Yeah, so you will construct sort of this boundary out of your use case, and it will be a mosaic of different things, and it will probably be a way that has not been implemented, right? It'll be really specific to you. The thing to keep in mind when building systems is, of course, everything not forbidden is compulsory. And so that is to say, given enough time, if it can happen, it will happen. I think the legal corollary to this is everything not forbidden is allowed. So like it's explicitly allowed. And so you should know that. If you have a gap in your security policy and two pods can technically communicate with each other, something will eventually happen that makes them communicate with each other. And that usually looks something like a data breach, right? Where one customer sees another customer's data, then you lose customer trust. So like it's a really complicated system, and you should know that when designing it. Cool. So if you were to go to your prompt today and say, I want to implement multi-tenant Kubernetes and I want this, B2B SaaS, all this stuff, it would grab the exactly wrong defaults, right? It would grab the defaults that are meant to solve your prompt and move you about to the next prompt in an economical way for Anthropic. And it would set you on this path where all of the default states are shared. There are no enforced security boundaries. And the insidious part about it is it would look like it works, right? Like you would get your demo running, it would be running on your laptop, and you would think, wow, this is awesome. Like it demos flawlessly, everything works exactly as I intended. You ship it, and then you end up like the guy in the Twitter conversation who says, hey, I built this awesome app, and then 2 days later, people actually use it and it crumbles and you don't know what's happening. And it's because of structural liability in your design. Cool. So these are some of the important decisions. So the isolation boundary is sort of that logical boundary of how you're going to separate your tenants. Are they going to be on the same cluster? Are they going to be on different clusters? That is irreversible, right? Like once you make that decision, if you want to change it, you're starting from a V0, right? Like you're starting on a new pattern, a new platform. There's no going back from that. And so a lot of times what that isolation boundary can be variable as well. So the scale from soft to hard, a lot of times that looks like if you use like if you go to use a web app and they have like a basic or a free tier, that will typically mean you're going into a public tenant versus something like an enterprise tenant where they're going to charge you more money, but you're going to get your own dedicated hardware. And so like that decision of how am I going to isolate my customers is irrevocable usually. Data isolation is more irreversible than the isolation boundary, but painful, right? Like anytime you're making decisions about where data lives for tenants, you're making long-term decisions. You can reverse it, but it usually involves downtime and it usually involves pain. The trust boundary is the most malleable. You can change the trust boundary just by changing like config or code, but it's the most sensitive to misconfiguration, right? So like a misconfigured trust boundary is usually a violation of customer trust, a data breach. It's the most critical part. Cool. So when you approach this problem, all of the defaults listed in the right are sort of like what you're trying to avoid. All of the implementations on the left are sort of what you're trying to implement, and you and your LLM are going to be attacking two different paths, right? And so we need to rebuild the friction, right? We need to rebuild the forcing function that makes us intentionally make these decisions instead of having them decided for us without our knowledge. So something that I commonly do is I put a systems design agent in my local agent harness. I call him Guilfoyle for anyone that knows the architect from Silicon Valley. And I say, hey, your job is to just be adversarial. And it's to question systems design, it's to question architecture, it's to interrogate frameworks, it's to force that agent to have a thoughtful consideration of these concerns. And I actually enforce ADRs even on projects that I work on by myself, right, with my agents. And so an ADR is a architectural decision record. It is literally just writing down why you made a decision, the context for why you made that decision, and it is an immutable log of the history of the things that you've decided, so that whenever you're going back and forth with your agents, they're not constantly trying to, oh, you should go use this framework because, and then have you ever made an AI, like you're working with something, you make a prompt and you get like 25 files changed and you're like, hold on, I was just working on, right? It's because it decided you needed something that it didn't find. And so this is a way to sort of redirect that energy to say, hey, these are the things that are decided. These are the reasons I decided them. Follow that pattern. Cool. And then I choose frameworks that contain complexity, right? Like I intentionally look for frameworks that contain complexity. We're going to talk some about those frameworks specifically to this problem. Okay, cool. So we have an arcade here on the left that you can play some really poor emulations of an arcade game if you're tired of listening to me talk. And then we're going to go through some of the source code. I don't know if this is going to break this display or not. Let's see. Okay, I'm going to assist. Just a sec. Oh, right on. Cool. Thank you. Sweet. So some useful things here, some ways to navigate. Probably the most useful thing that if you're involved in this at all, the infra directory is sort of just like a Terraform implementation of all these things as modules, and VPCs are separate from clusters, and like it's a useful implementation. I use it a lot. Some of the frameworks. And so the general idea is this is set up as like an apartment building. And so each floor of the apartment is a tenant. It's a different arcade game. There's a doorman where you can see like who's in which floor. Each room has its own chat box and high score tracking. And it's just to demonstrate this idea of multi-tenancy as a literal set of tenants. Cool. So some of the frameworks that this is a hodgepodge of a bunch of different implementations. You would like pick and choose things that you need. So Capsule is a newer framework that is actually designed for multi-tenancy on Kubernetes. It's like the first sort of complete holistic view of trying to encapsulate and abstract this problem in a single framework. Super useful. It enforces role-based access control based on namespace and based on budget and resource. It's really cool. It's new. I haven't used it in production yet, but I sort of like the development phase of it. Kyverno is like hard production tested. Lots of teams use it. It does pod mutation. So if two customers come to your app and you want them to connect to different databases, you would inject that at runtime as some sort of config, and Kyverno is sort of the policy as code, almost like Terraform is a declarative state, where you say, hey, I want this pod to get this treatment, I want this pod to get this treatment, and you sort of disperse that treatment across those different use cases. Otherwise, that lives in like an API layer, and it gets really nasty to try to like at runtime or like at the API call time to decide, hey, this customer came from, Acme, and I want them to have 10 gigs of RAM, and I'm going to apply that in the API. It gets really nasty. So Kyverno is a way to write that down as YAML, mutate pods declaratively, saves you a lot of complexity in your implementation. Cool. Helm, everyone knows Helm. It's just like ways to pass composable charts back and forth. And then Customize. Customize is an awesome tool that I use that does like dev prod stage overlays, right? So it helps you keep things dry, right? So you're not repeating code. You use one base, you define a base, and then you define the overlays for that base. And it's super useful. Cool. So you can run this locally. The version that you're on your phone, if you're on it, is running in AWS, but you can also run this locally just to like play with the policies, play with the mutating the different config and see what it does. Cool. So that's all I've got. I'm gonna stop, take any questions, comments, political dissertations. No questions. I don't believe it.
Going back to the slide that had the sliding scale for the different. Yeah. So is that and I'm very here. I'm not
Sure.
right? So is that you're saying the third option, dedicated nodes? So you might have an API node, you might have one running Postgres, you might have one doing this, that, and the other. Is that what you're talking about there as
Cool.
far as the cluster?
Yeah, good question. So dedicated nodes. So dedicated nodes are the VMs that are actually running under the scenes are different for each tenant boundary that you define. And so in practice, like in something like AWS, that looks like different compute worker groups, right? So that when you want a customer that you say, hey, you're going to share an API layer, like that handles your product, log in, log out, et cetera. But when they actually run their workloads, they're going to be on dedicated VMs that no other customer runs on, right? So that's sort of like a hybrid solution between everyone has to have a cluster and everyone runs on the same nodes. The primitives of Kubernetes kind of allow you to have multiple logical compute groups where the way you direct workloads to them is they have a system that it's called taints, where you basically tag pods and you say, I want you to run on this set of compute, I want you to run on this set of compute. And so it gives you like a hybrid option.
So as far as like a web application that might be hosted on the back end is like on some cluster, it wouldn't necessarily look like that. It would, because all the different nodes would have to talk to each other for those, wouldn't they?
Yeah, so you're saying if you had a web application and your web application is doing something, you would only have that would only be applicable if your customers for the web, like you're running some workload for them or you're doing some compute for them, that would be maybe redirected to those dedicated nodes. It's like configurable based on like the details of your use case. But like if you're just running like a typical web app like that you just go to, you're going to land on nodes that everyone else is using, right? So like if you go to Claude or something, you're running on shared nodes with other sessions that are running. Yeah.
Gotcha. Okay. Thank you.
Questions, comments?
Questions? Anybody?
Back here.
Way off.
see you walk over.
Yeah.
One of the challenges that I think a lot of people are facing these days is providing users across all departments an opportunity to develop an AI, but in a safe space. I'm curious what your thoughts are on leveraging Kubernetes clusters as a space to do that.
Yeah. So Kubernetes used to be controversial, right? Like a lot of developers used to say it was too much or it was overkill. You should choose it under a restrained set of circumstances. I think that's kind of waned away, right? Because the implementation is so easy now through coding assistance. I think that's like a great use case for it, right? Like um, so like I use it extensively on internal platform teams for very similar use cases where mine are more data focused, but it's a volatile environment where a lot of things can go wrong. Um, and we use it extensively for that. On the soft, like on this scale, on the soft side though, right? Like the component that as you move from soft to hard, your cost increase and your complexity increases. And so you have production out, it just requires more work. Like a soft multi-tenant Kubernetes implementation is not super difficult, right? Like it's pretty straightforward. Yeah, so option number two is actually pretty restrained, right? So there's a software implementation called vCluster, and it's it is but the gap between the first option and the second option is wide, and then the gap between the second and the fourth option is not that wide, right? Like once you choose vCluster, you're already on pretty isolated um, boundaries, right? So like if in most companies, I would pick the left hand, the first option, and you're going to be completely fine. You're all in the same network. It's totally fine. Yeah, awesome.
I'm dubious of learning things using AI because then I don't understand them. What resources would you suggest to learn and get better understanding of Kubernetes? I've not found the docs particularly
Oh
helpful
yeah, totally.
personally.
For sure. Yeah, awesome. So um, I use my agents to learn a lot. That's one of the primary things I use them for. And so one of the some of the things that will help you a lot is there are a lot of local implementations of Kubernetes. So Minikube is one of them. There's an application called Kind, which will actually run on your laptop. And so you can very quickly sort of prototype an idea, generate some iterations on it, and learn the primitives. So like you can use the kube command line is called kubectl, um, and get familiar with it that way. And then just find like a problem that you like and build the thing on it, and yeah, learn through doing. Cool. In the code repository it's built using Kind, and so like you can run it locally. Maybe not even run that locally, but like the setup for Kind or Minikube or whatever you choose is sort of like my first step. Okay, cool. Any other questions?
We got plenty of time for questions. Cool. Scotty Pate.
Awesome. Thank y'all.
Thanks, man.